So good morning once again. Hope the screen is visible.
Yes, sir.
Fine, good. So in the previous class, we discussed about a couple of programs on arithmetic operations. Now let us move to the branching and looping, the third category of instructions, which are very important from understanding point of view as well as from examination perspective. The one what is shared yesterday, hope you can get some insights into that. The type of requirement that has been given into the program. It is not like yesterday's program, something different is there, and some new instructions are also there in that. So that's what it is going to be. So let us look at those and hope you have your instruction sheet ready with you, because every time you write the program that you should keep with you, then only it is easy for you to understand what you are writing and why you are writing in the program. So coming to the program, so we are in the third category of programs which talk about branching and looping. First, let us look at SIC. Similarly, we'll try to write the same program in SIC-XE so that you can again see the difference between the SIC architecture as well as SIC-XE architecture in making the program more compact and more readable. Now, let us understand before we get into the writing of a program, the requirement of this program, that is copying the contents of a string 1 to string 2. Now let us not worry about what it is. Let us come back to our normal data structure where I have a string. You all know that a string is nothing but a sequence of a characters, maybe 2 or 3 or 4, any numbers, more than one character. If we group them together, I say it is a string. For example, welcome. Welcome is a string for me because it contains more than one character. And hello world, as you have taken in this program, that is also a particular word which I can say it is a string for me. So strings are nothing but, if you define as per the data structure, a sequence of characters which is made rather using the character set of a given language. What is a character set? Alphabets are characters, numerals are characters, and some special character like underscore, space, all those things are going to be characters. These are the characters what we have in any language. Similarly, SIC also has its own character set. More or less, whatever we know in normal high-level language, they're all available in the SIC or SIC-XE as well. So having said that, how to create a string? In a high-level language, in C, C++, you have seen that a string begins with a character, ends with a null character. What is that null character? That is only a notional representation inside the system that is the end of the character. So like that, depending upon the type of compiler, depending upon the type of architecture, depending upon the type of program you are writing, we have a different methodology to represent a string. But whatever the case may be, the string is going to be a continuous storage of characters or continuous sequence of characters depending upon our requirement. So let us assume now a string is available in str1. So str1 is a source now, str2 is the destination. So we have a string. Imagine a string now where memory is allocated. For example, let us take the same HELLO, there is a space, WORLD, hello space world. How many characters you see in that? Hello space world. What is the length of this string? Hello space world.
11.
11. Perfect. Because space is also a character. Agree? So we have 11, HELLO5, WORLD5. In between there is a space. Totally there are 11 characters available in a given string. We name it as a str1. So str1 is a source string. I need to copy the string contents of str1 to another string str2. What do you mean by copy? When I do copy, I'm going to copy verbatim. That means as it is. For example, str1 first position I have H. When I copy to str2, there also first position will be H. Similarly, fifth position here str1 is O. Similarly, in str2, fifth position will be O. Like that, as it is, whatever the positions I have in str1 will remain same in str2 as well. If that is the case, we have to copy from the same address of str1 location to another address, but with the same indexing. So we need to use indexing here because we are going to move like an array from base address to incrementing 111 after the one, because it is a string. We are having a character takes a byte of information or a byte of storage. So one byte every time we need to increment from the base address, so that we can keep on copying character by character. Why are doing character by character? Because in SIC right now we do not have flexibility to transfer more than a character. So we'll go to that particular concept of a copying the contents from one character to another character. So from str1, assume str1 is at the 2000 location. Now I need to copy the contents to str2. Assume str2 is in the 4000 location. So when I say 2000 is my location str1, so what is the total length of str1 now? 2000 plus 11, 2011. So my first bit or first character of str1 will be there at 2000. My second character, which is E, will be at 2001. My third character, which is L, will be at 2002. My sixth character, which is a space, will be at 2005. Like that, we are going to +1 by adding from the base address. Similarly, when I go to str2, whatever I have in str1 at location 2000 should come and sit at the location 4000. Whatever I have at 2005 in str1 should come and sit in the location 4005. So that 5 is a common factor. That's what we say it is a index. So even when you take an array, index remains same 1, 2, 3, 4 when you copy from one array to another array. What might change? Your base address might change. It doesn't matter. We are not worried about the base address, because we need to go to the position what we want, not the actual address, simply because memory is not in our control. We can only say the system that let the memory be used from this location. It may be possible, it may not be possible. We have been discussing that for some time. If that is the case, we are worried about the position now. That means if my character, my byte is available at 5th position in str1, the same character should be there in the 5th position at str2. That's what we mean by a copying a string as it is from one location to another location. In our case, it is from a str1 to str2. So that is a basic behind a string comparison or string copying, which you are all aware of that. So having said that, having this information in our mind, now let us attempt to start copying this now. Now, what is the prerequisite now? I have a string 1. The string 1 contains HELLO space WORLD, which is 11 character string. And now I have another string 2, which is an empty now, because that is a variable. Whatever I have in str1, I need to copy one by one to that. So str1 becomes your what you call already existing constant character. str2 becomes a variable string where I need to copy the content. So str1 is the source and str2 is the destination. So what we have to do now, every time when I want to copy, I cannot directly copy from string 1 to string 2. We have been looking at that. So anything that need to be copied, if you remember the first program, we copied back to the accumulator. From accumulator, we have fetched that and stored in the destination. Same process we need to follow. So for that purpose, we know there is a LDCH. So LDCH is what? Is a instruction that copies or that takes the data rather from one position and stores back into the accumulator. Similarly, what is STCH? It takes the data what is there in the accumulator and stores into the another register. So if you compare the first program what you have taken, we have written LDCH5, STCH, LOC something. So what is that? That was the location from where we have taken the data. Now what is the location for us now? str1 is the location, which is a source location. str2 is the location, which is a destination location. The extra what you have written is a x1. Why you have written x? Because we have a string, the base address remains same, only x value will keep on changing. That is the index register or index value or the subscript of your array. If that is the case, probably we require X register that need to be incremented from 0 till you reach the end of the string. So that is the purpose we have a LDCH. It's not only str1. Now we have to take one character at a time. So it is str1 comma X, meaning that we are going to use index register. Next, STCH means whatever the character I have in accumulator, it should go to the same position. So X is used at LDCH, I should also use STCH also X. But what is the difference now? We have to use a destination. From one location, I'm going to store at another location. So my source is str1, but my destination is str2, but the index remains same. If it is 0, it should be 0 in the other place. If it is 3, it should be 3 in other place. If it is a 9, it should be 9 in other place. That is the case. I need to maintain the same X so that my purpose of copying the string 1 as it is to str2 will be served. So with that concept now, we have written LDCH str1, X, STCH str2, X. Now, what is X here? X is a index register. Even if you remember in loops, for I is equal to 0, I is less than 10, I plus plus, you keep writing. Sometimes you write I is equal to 1, I is less than or equal to 20, I plus plus, I minus minus. So you are initializing that. I is equal to 0, you do sometimes. I is equal to 1, you do sometimes. So similarly here, we have a flexibility. If you want to have a 0 as your starting address for your index, you can initialize X register with 0. You want to start with 1, you can start. You have a flexibility like you do in array. Sometimes you write for I is equal to 0. Sometimes you write for I is equal to 1. Accordingly, you write your program. Similarly here as well, you need to initialize the register, X register with the proper value. Here I have used a 0. If you want, you can make it 1. No problem here. But you have to initialize before X is being used. That's what is being done now. So LDX means we are going to load X register with what value? 0. Why we are loading with 0? Because we are initializing the register X, which is an index register, because I need to increment 1 by 1 by 1. Why it is 1? Because string is nothing but a group of characters. Character takes 1 byte at a time. So that's what is being done now. So we have initialized now. We have loaded the character in accumulator. The same character is loaded back to the destination, that is str2. Now what we have to do now? One character is over. Now I need to take the second character, third character, fourth character, fifth character. Like this, I need to go back till the end of the string 1, so that once I reach the end of the string 1, I can conclude that I have copied everything. But how do I reach the end of the string? So we know that the string what you have stored here is containing 11 characters. So what I advise is go to your instruction set. There is an instruction by name TIX. Read that instruction and understand what is the purpose of that. Go to your instruction set, TIX. There is an instruction because your instruction sets are in alphabetical order. Observe where TIX is there and look at the composition of a TIX. How it is made, what type of instruction it is, what happens when you do TIX. Could you go through that? Able to figure out? Could you see TIX?
Yes, sir.
Yeah. What is the requirement of it? What it will do? Because we know we are going to use instructions as per the whatever the profile we have given for SIC manual. I can't use something else. So I need a purpose now. I need to increment the value of X. And at the same time, I need to compare. So for I is equal to 0, we have done. Now I need to check whether for I is equal to 0 is less than n or not. Then I need to increment. So I plus plus, I less than or n. I need to do this. How do I do that? Do we have one instruction? Do we have two instructions? How do we do that now? So TIX, if you have looked at, TIX stands for incrementing X register. Not only incrementing, it also compares the content. It is like a T command in your Unix. You have seen TEE command. What TEE will do? it will do two things at a time. What are they? It will display the contents on the screen. At the same time, it will store the contents into a file. So same command will do the same thing. I mean, two things. Similarly here, TIX is a command. As name says, it is going to increment the X register. That is the index register. Not only that, it also compares the contents of the whatever the operand it has got with the X register. So what we are now, X is 0 now. When I go to TIX, what will happen? X gets incremented. So 0 becomes 1. And that means you have moved to the next character. So the next character is within the range of 11 or not. So we have to compare with the 11. Why it is 11? Because that is the length of the string. Tomorrow I may take welcome. Welcome is going to have a 7 characters. So my TIX will be 7. So depending upon the what type of string you have taken, the length of that string is going to be used here for comparison. So TIX basically does two things. One is incrementing the contents of X. So far contents of X is 0. It becomes 1 now. That 1 is compared with 11. So 1 is less than 11. So I need to repeat the same process. Why? Because I need to copy the contents from str1 place to str2 place 1. Similarly, next str1 second place to str2 second place. Like that, I need to do up to 11 characters. So I need to look out a mechanism where these statements are repeated for some time. So then I need to go for a loop. What is a loop here? The loop is going to be LDCH str1, X, STCH str2, X, ticks 11. So keep on repeating this until I see that the value has reached 11 or the value what I see is going to be more than 11. So until that, I'm going to repeat these instructions. Thereby, the third column, the first column, which is the label column, is added. If you look at left hand side to the LDCH, we have added a loop. Why it is that? Because from that point onwards, I need to repeat the instructions until I get the my 11 characters being copied into the destination. So thus I keep repeating. Suppose I do up to 11 now. So I will be comparing my 3 to 11, 4 to 11, 5 to 11, 10 to 11. All this time my value is less than. So jump on JLT here. We have used another instruction. JLT stands for jump when the previous value of X is less than 11. So less than 11 means we know that we have a SW, status code. Status code will be updated every time when TIX 11 is executed. Based on the less than value, if it is less than, that is if it is less than 0 or negative, it will be going to the loop whatever we have. So in our case, it is less than value, we are going to copy, we are going to continue with the same loop. So once it becomes 11, it is not less than 0, it is equal to 0, meaning that all the 11 characters have been copied into the destination. So you come out of the loop. So until the value is not 11, until the value becomes 11, we will be keep on repeating this. Once you become 11, you are going to come back out of it. When that means you have copied all the values from the str1 to str2. Since you have taken 0, we are taking TIX 11. If you have taken LDX as 1, TIX would have become 12. So that normally we do in high level language. Here also all those things are going to hold good. But whatever it is, you have to compare properly to make sure that all the characters of a given string are copied as it is to the destination string. This is the program. But that is not the end of the program. As we know, we need to define the undefined things. What are undefined here? 0 is not known to the system. str1 is not known to the system. str2 is not known to the system. 11 is not known to the system. Loop is not known to the system. But loop we have already put as a label, and hence loop is already defined. Remaining 4 we have to define. What are they? 0. 0 is a constant, so it becomes a word. 11 is also constant, it becomes 11. And string 1 we have seen already in the first program. Dealing with the characters, we have to prefix that with a C within quotes, whatever the character you want to write. That's what we have written, hello world, because there are the character constants. Next, we have a str2, which is a destination, which has to be contain something, and hence it is a variable. So we have written resb. Be careful. Str1 is a byte because we have a character constant. str2 is a resb because it is a location or the destination or the variable at which I need to store, and hence 11 characters of length or 11 bytes of data has been reserved for this. So this is how the program of a branching and loop. Two things we have seen here now. What is first one? Index register also we have seen, and how a looping is going to be performed is what we have seen. So go through that again. Once again, if you have any doubts, we can discuss. Meanwhile, let me take the attendance. Asta?
Present, sir.
Abhinav?
Present,
Aishwarya?
Present, sir.
Ambrish? Anu?
Present, sir.
Arbaz?
Present, sir.
Arjun?
Present, sir.
Ashok?
Yes, sir.
Vinita?
Yes, sir.
Present, sir.
Ambrish? Ambrish? Bhargavi?
Present, sir.
Bhavisha?
Present, sir.
Chaitra?
Present, sir.
Chatterjee?
Present, sir.
Diksha?
Present, sir.
Deepika LG?
Present, sir.
Deepika MB?
Present, sir.
Murli Krishna?
Ah, sir.
Present, sir.
Ambrish Idiyappa? Gangubai?
Present, sir.
Guriya Kumari?
Present, sir.
Harshit?
Present, sir.
Junjar Singh?
Present, sir.
Kavya?
Present, sir.
Kishore?
Present, sir.
Yaro? Who is present?
Sir, Kishore.
What happened, Kishore? You were absent for a long time.
There are some problems.
Hope you are healthy. Hello?
Sir.
Hope you are healthy. Safe.
Yes, sir.
Okay.
Now I am, sir.
Okay, fine. Lata?
Yes, sir.
Manisha?
Present, sir.
Manjunath?
Yes, sir.
Nayana? Nilanjan? Nishant?
Present, sir.
Who? Nishant or Nilanjan?
Sir, Nishant.
Okay. Pavitra?
Present, sir.
Maithili?
Present, sir.
Priyanka?
Present, sir.
Pavan Kumar?
Present, sir.
Akash?
Present, sir.
Rajeshwari?
Present, sir.
Rakesh?
Yes, sir.
Ramya?
Present, sir.
Rashmi? Ravishankar? Rizwan?
Present, sir.
Vishal?
Present, sir.
Savita?
Yes, sir.
Shruti?
Present, sir.
Sneha?
Yes, sir.
Spurti?
Present, sir.
Srinidhi? Srinivas?
Trinity present, sir.
Srinivas? Sunil?
Present, sir.
Who? Sunil? Sunil? Vaishnavi? Vinny?
Present, sir.
Okay, fine.
Present, sir.
So any doubts in this program?
Sir, Rashmi present.
Sir, Amrish present, sir.
Ambrish. Okay.
Sir, Rashmi.
Rashmi. Okay. Yes. Any doubts? No doubt?
Sir,
Yeah, please.
sir, in STCH line,
Ah,
Like yesterday you told left one is source and right one is destination, no sir.
Yes.
So here string 2 is the destination.
Hmm.
Then why you wrote str2 in place of source?
Okay. See, STCH is the instruction. The purpose of that is to store the data from accumulator to one place. That place in this instruction, see, you have to look from that particular, no doubt str2 is a destination. In instruction STCH, str2 is in the destination position. So I can use str2 for some other purpose in another. For example, if I write LDCH str2 in another instruction, what will happen? LDCH means what? Loading my accumulator with data. So where from I am getting the data? str2. So str2 becomes a source for LDCH. But when you look at the instruction in the operand, when I say str2 comma str1 or str1 comma str2, when I'm involving more than one operand, especially in arithmetic, not in these normal cases. When I'm doing arithmetic, for example, when I do 2 plus 3, 3 plus 2 doesn't matter for me. But assume 3 minus 2 and 2 minus 3. Obviously, it is a problem. So when such situations are there, we are going to have a issue. There your source destination concept is going to be very, very critical. But don't look at str2 is a destination, STCH why am I using? That is not the way we should be looking at it. So STCH is one instruction. Each instruction is a unique here. Don't compare with LDCH when you are with STCH. When I am in STCH, what STCH will do? It is going to store the contents of accumulator to somewhere. What is that somewhere? That somewhere is str2. That's all. For STCH, str2 is a destination.
Okay sir, thank you.
Yeah. I hope it is clear.
Yes sir. Yes sir.
Yes, okay. Fine. If you have no doubts, so you can rewrite this program in SIC XE. So next one is write a program to copy contents of str1 to str2 using index addressing in SIC XE. In SIC XE. I will show the program. Copy this first, then we will see how this is being written. So when you write the program, follow the structure. Label, opcode, operand. Over. Fine. Now, so same program we are trying to attempt in a different architecture, that is SICXE. We know that SICXE is better compared to SIC in terms of the flexibility that is given to the programmer to write a good program. And probably will appreciate that if you look at this program looks crisp and this program looks more readable compared to the previous program that we have been observing in every alternative way of looking at SIC and SICXE concept. Now, as usual, index register we need to use. So we need to load the index register with initialization value either 0 or 1 depending upon you, and we have taken it as 0 now, so we'll continue with that. So LDX is loaded with 0. Since immediate addressing is there in SICXE, we try to utilize that. So LDX hash 0. Now I want your attention to go back to your instruction sheet. Go to an instruction by name. You have just now seen TIX. Next to that, you will see one more instruction by name TIXR. Go to that and let me know what is the second column.
Format 2, sir.
Format 2. Yesterday, we have seen some other instruction by name ADDR. Do you remember that? ADDR, SUBR, MULR, DIVR. So what is that R we discussed? Whenever there is an R suffix, it means it is going to be involving registers. When we say involving registers, 90% it is going to be format 2 register type. Thereby, by looking at instruction, if it is suffixed with R, we can conclude that it is going to be more or less a format 2 type of instruction. Format 2 concept is opcode, register 1, register 2. So if you look at the TIX, what you have just now seen, TIX purpose was to take the content of a variable, increment the command, take your X content, increment that, compare with the value what is being written. We have written TIX 11 in the previous program. But now we are going to utilize one more register such that we can compare two registers. Already X is a register. I have this flexibility of taking TIXR, which is in SICXE. In SIC, it is not available because you don't have format 2 there. It is only format 3. Now, the TIXR I am going to use to compare whether my value is 11 or not. If it is 0 to 11, 1 to 11, 2 to 11, 3 to 11, I keep on comparing that whether it is reached my 11 or not. For that purpose, I am going to use another register. That register is required for me here to use the TIXR. So I'm not going to declare a constant here, but I will use the register which is available. And we also know that it is better to go for a 2-byte instruction rather than going for a 3-byte instruction we have seen already in the previous program. Likewise, I need to initialize another register by name SRT. I have flexibility only with SRT. S and T are the general purpose registers. If you want, you can use T, or if you want to go with S, you can go with S. Both are fine. So if you want, you can write LDS, or if you want, you can write LDT. Both you can use, but not any other register, because they have the intended purpose. Only S and T are there for a general purpose. You can use them the way you want. Even in one of the previous class programs, we have used S as a register, and we have compared we have performed the addition operation. Same wise, you can use S or T. Since it is an address where since it is a register which is being used for a comparison purpose, I would like to store my value of the length of the string, which is 11 for me. So in one register, I have 0, initialized value I is equal to 0. In another register, I have a I is less than or equal to 11. So this is what I have done with the LDX hash 0 or LDS hash 11. So now my initialization part is done. The remaining two, that is LDCH, str1, x, STCH, str2, x remain same, because I need to consider each character of the string copied into the another string through the accumulator. That is going to remain same. Those two instructions will come as it is. Now extra here is, instead of TIX, we have used TIXR. We have just discussed now why we are using TIXR. There are two purposes. One, TIXR takes 2 bytes. where TIX takes 3 bytes. So better to go for a 2-byte instruction. And second, we are flexibility of using general purpose registers. We are trying to use them. Thereby, we can reduce the size of the program. That's what we are going to do. So TIXR followed by S. Why S? Because we just know we have used LDS. If you have taken LDT, you write here TIXR T. Depends on what register we have. So what is the purpose of this now? Same purpose. It increments the X register, compares the content of X register with the contents of a S register. So initially X is 0, X becomes 1, 1 is compared with 11. Instead of writing separately, we store that value in a register. That's all the difference. Same comparison happens, same less than loop. If it is less than 11, you keep on performing the loop, and we know how to write the loop. We have written that. That same continues until you reach the 11 characters. Once everything is over, you come back to the next one, that is going to be your assembler directives. So which are undefined here? str1, str2, and loop. So loop is already defined now. str1, str2 we have defined. So str1 is a source string, so byte, C, hello world. Whereas str2 is a variable we have loaded with the 11-byte storage space, so that I can copy the contents from str1 to str2. So hope it is clear. Go through that quickly. If you still have any confusion, we shall discuss. If you don't have, take an assignment question. Two questions already given. This is a third question. Write SIC program. Write SIC program. To clear, right, SIC program to clear the contents of a 20-byte string, 20-byte string with blank spaces, 20-byte string with blank spaces. Next, fourth one, write a program in SIC to add two arrays of 200 integers each. Two arrays of 200 integers each, and store the result in a third array. And store the result in a third array. So these are the two questions. One more question I will give maybe at the end of this class. These are the four. With that, 5 questions, your assignment 1 will be complete. So after completing all those 5 questions only, you submit. Okay, if you are done, I will go to the next and last category, that is IO instructions. Okay. So now the IO operation. So we know in SIC, IO operation is performed 1 byte at a time. And the instructions that are used is a TD, RD, WD. So TD is for testing the device, RD is for the reading from the device, WD is for the writing into the device. So now we have a device. What is the device? Maybe your printer, your screen, keyboard, all those things are going to be devices. And internally, we know in Unix we have seen device file names are given. For every device what you have connected, through your system, maybe a printer or a scanner or a mouse or a keyboard, whatever it is, all the peripherals are internally represented with a name, which is a unique name again, and those names are given as a device names. So accordingly, we have written the program here. So take the question now. Consider, you can copy this. That's better. Before we discuss, you can copy this program. This entire program is single program. I have divided for your understanding, but it's a single program. You can copy this. We'll discuss in 2 minutes. Yes, the requirement here is we need to read a 1 byte of data from a device by name F1 and copy that into another device by name F2. So imagine I have a printer and I have a pen drive. So from printer device, I can take from a pen drive and I need to give it to the printer device. So how do I do that now? To communicate, I need a temporary in between, a mediator. That mediator is nothing but always your accumulator. So accumulator acts as a mediator because printer is a different device, your pen drive is a different device. So from pen drive, you copy into your system, later you give the printout. That's what we do. Same case here, from your pen drive, you copy into the accumulator, from accumulator, you transfer that into the another device. So without accumulator, you cannot copy the contents directly from a pen drive to your printer. So without system, can you imagine telling the pen drive to take a print from a printer? Not possible. In the similar fashion, we need an accumulator in between to take the contents from F1, store it, later transfer back to the F2. We are going to do precisely the same concept. So first one is we need to read the data from the device F1. The first loop is about that. Second loop is nothing but storing the data back to the another device. Let us see what is being done. And we know that before we start transferring data, we need to check whether device is ready or not. We have seen earlier also, TD is the instruction which makes sure that the device, if it is ready, the process can be happening. If it is not ready, we need to be checking again and again and again until the device becomes ready. So for that purpose, we have written TD input. Input is a input device. We are giving a name for it. What is that input for our understanding? So from the input device, we are going to read the data. Before reading, we need to test whether that input device is free or not. Free means what? It might be used by somebody else, or if it is not having the data with it, then we cannot do any reading purpose. So we need to check that. That is the idea behind the testing the device. So we are testing TD. So how do you know the device is ready? So when we test, accordingly, your status word will be changed. So if the device is ready, one value, which is a 0 value, will be highlighted. So when 0 value is highlighted, then I say that this is what it is going to be. When it is not highlighted, then we say this is not ready. So in SIC, when the value of testing is equal to 0, then meaning that the device is not ready. When the value is 0, the device is not ready. If it is any other value, the device is ready. So when you test the device, input device here, if it is 0, what do you mean now? device is not ready, I need to again check, again check, again check. So I need to be in a loop now. That is the reason why TD, the label is LOOP, because I will check the device. If device is not free, the value will be 0. If the value is equal to 0, I will go back into the loop. So when I will come out of the loop, only when the value is other than 0. What do you mean by value other than 0? Because the device is ready. So ready means I can start engaging with that either for a read purpose or a write purpose. So once the value is not 0 or maybe 1 or 2, whatever it is, now my device is ready. I am going to read the data from that. For that purpose, I have a RD. So RD is the instruction that reads the data from input device and stores into the accumulator. Now I have the data in the accumulator. Now from the accumulator, I'm again storing back to another location called DATA. So from the input device, you have taken the data into accumulator. From the accumulator, we are stored in some place. We are doing that only from the safety perspective, because we should not be losing the data for whatever the reason. So we have kept the data now and some repository. Why it is STCH? Why not STA? Because it is only 1 byte. Please remember, we are transferring 1 byte at a time. And hence I cannot write STA. It is only STCH. Okay, that is one part. Input has been taken and stored into a location. Now other way we have to do. So from the place data, we need to store back to the another device called as a output device F2. So again we need to check whether that device is free. Same process continues. Test the device, but here it is not input device, it is a output device. Again check whether it is equal to 0 or not. If it is equal to 0, I need to go to the loop. So be careful here. If you look at LOOP, I have used already. I cannot use that again. If you write LOOP, system get confused and it will go back to the beginning. It becomes a indefinite loop. For that purpose, I need to differentiate the previous loop and this loop. You can give any name of your choice. Labels are user defined. You can write L1, L2, L3 as long as you can understand. I'm writing loop for your understanding, but you can write anything. But at any point of time, no two names of loops will be same. That's what we have to look into. Loop name should be unique always. So since I have used already loop, I'm using loop 1. So JEQ, that is when my device is not free. Which device in this case? Output device. I'm going to check it again and again and again. So once it is free, then I know that I can load the data from my accumulator to the output device. So since the data is not in accumulator right now, it is in some location, I will transfer back to the accumulator. You could have avoided this, but as I said, we are doing this because accumulator is very, very, very sensitive register. If you are not taking the data care properly from accumulator, there are all chances that you may lose the data from accumulator. That is the reason why we have stored in a location. Now from the location, we are taking back to the accumulator. So LDCH data. So data is the location where we have just now stored the data. From that, we have taken the data back to the accumulator. Now from accumulator, I can transfer into the output device using the WD. There we have read. Now we are writing into the device. That's all the difference here. So WD means I'm writing into the device. Which device it is? Output device. So we have read the data from input device, stored into accumulator. Again from accumulator, we have stored back to the device. This is what we thought in the beginning, and purpose is served now. So after this, whatever is undefined is there, we have to define. Input is undefined, loop is undefined, data is undefined, output is undefined, loop 1 is undefined. So here loop and loop 1 are already defined, so nothing to worry. Remaining is input, data and output we have to define. So what is input here? Input is a device. What is output here? Output is a device. So please be careful here. Since it is a device name, we are not going to give C here. We are giving a X. Please observe here. Input byte X. So far we have written C for every character that we have used, but we are writing X only to denote the system that it is not a normal character, but it is a device name. That is F1, F2, F3, whatever name you are going to give for a device, D1, D2, D3. You can give any name. That is a name. It is not a single character here. It is a complete name that is going to be considered here. So when you're dealing with the devices, you should be prefixing X. dealing with only characters, then you have to prefix with a C. That clarity you should have here. So input and output are the devices. So X is being used in the place of a C. So please observe that. And the last one is the data. Data is only a location where I'm going to store the data, which is a 1 byte data. So I'm going to reserve it as a variable which can store a 1 byte of data. So that is the program about how IO operations can be accomplished in SIC. So this is what we have from the IO perspective. Please go through that. If you have any doubts, let me know. We are not writing SIC-XC version here. As I said, SIC-XC IO is totally for a channel where I want to send 100 bytes together. So we are not going for that because that is of no use for us. Just this program is to give you an idea how SIC can transfer the data from input output. Most of the input output is not in our control. So you just transfer the data from one device to another device. So these programs are almost inbuilt. So just to give an idea how TD, WD, RD is given, RD is used, this program has been considered. Nothing to worry about SIC-XC because it is a channel of data. Just repeat the same instructions using that. That's all is HIO, SIO and TIO. So nothing to worry about that. But just understand the way IO operations are being accomplished. So if you are done with, I'll give you the last program for assignment. You can complete that. So if you have any doubts, please let me know. Fine. Take the last program. Write a program. Write a program to read. Write a program to read 50 bytes. To read 50 bytes from input device D2, from input device D2. As I said, names of the devices can be anything. You can say dog, cat, monkey, no problem. But be careful. Input always need not be D1, D2, F1, F2. It can be anything. You need not worry about the names. From input device D2 and store it another device. Store it another device. Data. Store it another device. See, now the device name is given data. Just to confuse you, nothing to worry. Store at another device data. So what is we have to do? What we have to do here is similar to this program, but we have to repeat the same concept for 50 times. So your looping will come into a picture, and this program becomes much more complex. That's all we have to do. So one more loop will be added here because you need to copy every time one character. Transfer, one character transfer, you do this up to 50. So this program is nothing but this program plus your indexing program. Combination of that becomes your solution for this. But try, if you can write the solution for all these three programs, that gives confirmation and confidence to you that you can write an assembly level language program. So I want you to do that, and this exercise will help you to understand how to write the programs. Anyhow, if you have any doubts, I'm always there. You can let me know in writing the programs. But this is how the assignment probably you can accomplish. So this concludes your assignment 1. So once you do, you can send it to me maybe by Monday. So you can do this, all these exercises and submit by Monday. So any doubts at this point? If you don't have any doubts, probably I'll conclude this class. We'll meet in the next class with the assemblers.